Alright, now let's start with a different subtopic. We're going to talk a bit about law of thermodynamic. It is not part of the syllabus, but you did learn this in your Form 1, Form 2, Form 3 science. In law of thermodynamic, we talk about energy cannot be created nor destroyed. It changes form from one to another. For example, the light coming from this light bulb originates from electrical energy. It is converted to light energy and heat energy. Now, how is this related to your topic? Is that in chapter 2, we have the law of conservation of momentum. The idea of law of thermodynamic and the idea of law of conservation of momentum, they share the same concept. In the law of conservation of momentum, we say that the total momentum before collision is equal to total momentum after collision. And when we take a look at momentum, momentum is known as the product of mass and velocity. So when we have an object that is constantly moving, what happens is that we can calculate its momentum using the formula of P equals to mv, where m is your mass and v is your velocity. Let's say an object of mass 2000 kilogram is moving with a velocity of 10 meter per second. We can calculate its momentum by simply multiplying the two numbers together. So here we have 20,000. The unit for momentum is very easy. We just take the unit of mass and the unit of velocity, combine together, and you get this. Now, please remember that all the basic SI unit, the mass is always in kilogram, speed is always in meter per second. If, let's say, the question give you in kilometer per hour, convert it first to meter per second. For example, if, let's say, they give you 180 kilometer per hour, what you can do to convert it to meter per second is you times it by 1000 and divide it by 3600. Why? Because in 1 hour you have 60 minutes, in 1 minute you have 60 seconds. The product of both will give you 3600. This is how you want to convert your kilometer per hour to meter per second. Now, let's look at our collision. We have 3 different collision that we're going to learn. The first one we have is the elastic collision. In elastic collision, you have 2 different objects moving against each other, hitting one another, and then move separately in different direction. So in elastic collision, we use the formula m1u1 plus m2u2 equals to m1v1 plus m2v2. So if I were to give in the form of a diagram, what happens is, let's say I have a ball, and this ball is moving with a velocity of 2 meter per second, having a mass of 0.1 kilogram, hitting another ball, having an initial mass of 3 meter per second, and Let's just say it has a mass of 5 kilogram. After the collision, I want to find the speed, the final velocity of the smaller ball. So what happened? Let's say both of them move in the opposite direction. Here we have 1 meter per second, and here we don't know what's the speed. Let's just say this is the scenario. So how you want to calculate the final velocity on this side is that you use the formula straight away. 2, 0.1 plus 3, 5 equals to 0.1 times with your v plus 1 times 5. This is how you put into the formula, and you can compute this using calculator straight away. Move this to the opposite side, it becomes a minus. Move the 0.1 after you solve the whole thing, divide it by 0.1 and you get your final velocity. Stop. So when you compute this calculation earlier, what you're going to get is something like this. Just move this to the opposite side, it become a minus, and move the 0.1, it become a division. So here you have 10.2 divided by 0.1, you're going to have 102 meter per second. Of course, this is not a realistic number. I'm just giving an example. Now, next, aside from elastic collision, we have the inelastic collision. In inelastic collision, when two objects they collide with one another, what will happen here is that the object will move in one direction. They are bound to one another and move in one direction. Or they can also collide and one is moving in one direction, both of them same direction, but they don't combine. This might move slower than this one. It still be considered as inelastic collision. So what we see in elastic collision, we can see the formula of m1u1 plus m2u2 equals to the total mass of both objects multiplied with the final velocity. Now, in this inelastic collision, we have two objects. Let's just say this is 2 kilogram. The speed is 1. Hitting with another object, 3 kilogram, the speed is 2. And let's just say after colliding, they move in the same direction. And we want to find what's the final velocity. So what we do is we times the 2 with the 1 plus 3 with the 2 equals to the total mass of both of these objects, 5 times with the v. 2 plus 6, you're going to get 8 divided by 5, and basically your velocity, you're going to get 1.6 meter per second. Now, aside from inelastic collision,